Welcome back to the Deep Dive. So glad you could join us today.
Great to be here.
We're diving into something really foundational today, especially if you're involved in healthcare facilities, design, running them, you name it.
Absolutely. We're looking at the National Fire Protection Association's code, NFPA 99.
Right, the 2021 edition specifically. And we really want to focus on what this means for, say, a dental clinic setting.
Exactly. And, this isn't just some optional guideline. NFPA 99 is crucial for keeping both patients and staff safe in any healthcare environment. And dental offices definitely fall under that umbrella.
Mhm.
It's worth remembering NFPA 99 actually changed from a standard to a code back in 2012.
Oh, okay. What's the significance of that shift? Standard to go.
Well, it signals a move towards something more intended for mandatory adoption and enforcement by authorities. It gives it more teeth, so to speak. But the really big change, also from 2012, was the shift to a risk-based approach.
Okay, risk-based, that sounds key.
Yeah.
What does that mean, practically speaking?
It means the level of safety features required for things like medical gas systems, electrical power. It isn't just based on whether it's a hospital or a clinic anymore. It's based on the potential risk to the patient if that system fails during a procedure.
Ah, I see. So the procedure's risk dictates the system requirements, not the building type.
Precisely. So a procedure with a certain level of risk needs the same level of system safety support, whether it's happening in a huge medical center or a small outpatient office. It's a fundamental shift.
Got it. So that's the lens we need. Our mission today, then, is to pull out the key takeaways from the NFPA 99 text you've provided, specifically focusing on those engineering and safety requirements for dental clinics.
Right. We'll look at mandatory systems, any space considerations, and try to pinpoint the specific sections that really apply.
The goal is to make this dense code a bit more digestible for you, the listener, especially if you're navigating dental facility design or operations.
And it's good to see, looking through the committee list in the source material, there was actually a representative from the American Dental Association on the technical committee for NFPA 99.
Oh, that's interesting.
Yeah, it suggests that dental considerations were definitely part of the conversation when this code was being developed. They weren't just an afterthought tacked onto hospital rules.
That's reassuring. Okay, let's start with that foundation then, the risk-based approach. How does this concept, introduced back in 2012, but central to the 2021 edition, shape how a dental clinic gets classified and what rules apply?
It really changes the whole game. Before, you might have had a chapter specifically for, say, dental facilities. Now, you have to start by assessing the risk. Chapter 4 of the code lays out how to do this.
Chapter 4.
It defines 4 categories. Category 1 is the highest risk system. Failure is likely to cause serious injury or death. Think major surgery, life support. Category 2 is where failure is likely to cause minor injury. Category 3, and this is where dental often lands, is where failure is not likely to cause serious injury or death. And Category 4 is the lowest risk, where failure has minimal impact on patient care.
So you figure out the risk category of the procedures first.
Exactly. You determine the risk, then you apply the requirements for that specific category. The code doesn't care so much if it's a hospital wing or a standalone clinic. It cares about the risk level of what's being supported.
Okay, that principle is clear. So how does a typical dental clinic, or maybe specific areas within it, usually get classified under this system? Where do common dental procedures fit? Cat 1, 2, 3.
Well, that's the million-dollar question for applying the rules, isn't it? The source text doesn't give us like a definitive list saying this dental procedure is category. However, it gives really strong pointers when you look at the sections dealing with the systems used in dental.
Ah, okay. So we look at the systems.
Yeah, check out section 15.4. It's titled Dental Gas and Vacuum Systems. Now, that whole section, 15.4, falls under the part of the code dealing with Category 2 and Category 3 piped gas and vacuum systems. Even more telling, section 15.4.3, which covers dental air and piping systems, the air for handpieces and such, explicitly calls them Category 3 systems.
Ah, okay. So the code itself points to Category 3 for those core dental systems.
Yeah, it strongly implies it, yes. By structuring the requirements for dental air and placing the broader dental gas and vacuum section under the Cat 23 umbrella, the code is basically setting Category 3 as the default framework for these typical dental support systems.
So things like dental air, suction.
Right. And likely the piped nitrous oxide systems too, as section 15.4.2.6, which addresses those other dental gases, is also within that Category 23 structure.
Even for sedation, maybe.
Based on how section 15.4 is organized in the source, it seems the infrastructure, The pipes, the sources, the alarms for these systems in a typical dental setting are being primarily addressed under Category 3 requirements. Now, the code always allows, even encourages, a facility to do its own specific risk assessment based on Chapter 4, but the way the dental-specific sections are written gives us a very clear starting point. Think Category 3 for these piped systems.
That makes sense. I also saw a definition in there, section 3.3.169, for single treatment facility. It talked about a diagnostic or treatment complex, single management, contiguous use points.
Yeah.
That sounds an awful lot like a typical dental office setup, doesn't it?
It really does. It captures that common footprint perfectly. A group of treatment rooms, maybe a lab, sterilization area, all under one roof and one management. So the process is determine the risk category, likely Category 3 for most of these systems, and then apply the Category 3 requirements to the systems and spaces within that single treatment facility.
Okay, great. So the risk points us to Category 3 for these key dental systems. Let's really dig into the details now. What does NFPA 99 demand for these medical gas and vacuum systems, dental air, vacuum, maybe nitrous under that Category 3 designation? Sections 15.4 and 5.3 seem critical here.
They absolutely are. Section 15.4 has the dental-specific rules, but it constantly points back to Section 5.3 for the general Category 3 system requirements. And 5.3, in turn, often references Section 5.1 for the foundational rules for all medical gas systems. So you kind of have to read them together.
Like layers of requirements.
Exactly. Let's start at the source, the equipment making the air or vacuum, so compressors, pumps, maybe cylinders. For Category 3 medical gas source equipment, Section 5.3.3.6.11 gives a pretty significant allowance.
Oh yeah, what's that?
It says components like the medical air compressors, the dryers, aftercoolers, filters, regulators, they're permitted to be simplex.
Simplex, you mean just a single unit, no automatic backup required?
That's right. In higher risk categories, like Category 1 or 2, you'd almost always need duplex systems, 2 compressors, 2 dryers, etc., configured so if one fails, the other takes over instantly.
Right, for critical care.
But for Category 3, like in many dental applications, the code says a single unit for the air system components is acceptable. This is a major cost and space difference, reflecting that lower risk assessment, a temporary loss of dental air, isn't likely to cause immediate serious harm, unlike, say, loss of oxygen in surgery.
But you still need all those components, right? Compressor, dryer, filters.
No, absolutely. You still need the full sequence to ensure the air quality meets the medical air standards: dry, clean, free of contaminants. That part doesn't change. It's just the redundancy requirement that's relaxed for Category 3 air sources.
What about the vacuum pumps? Same simplex allowance.
Ah, interesting point. Section 5.3.3.7 handles Category 3 vacuum. It mostly refers back to the general requirements in 5.1.3.7, which apply to Categories 1 through 3, but it does allow for some Category 3 specific exceptions. Now, that general section, 5.1.3.7, does typically require multiple vacuum pumps. Enough capacity so the system works even if the largest single pump is out of service. It also requires things like automatic backflow prevention, isolation valves, and a receiver tank.
So vacuum might still need redundancy, even in Category 3.
Generally, yes, based on 5.1.3.7. You'd have to look very closely at the specific exceptions mentioned in 5.3.3.7 to see if there are any breaks for dental vacuum systems, but the starting assumption based on the main section is some level of pump redundancy. It highlights a difference in how the code treats loss of air versus loss of vacuum in this context.
Okay, that's a key distinction. So if you can have a single air compressor, how do you know if it's working correctly or if there's a problem? What about monitoring and alarms?
Monitoring is absolutely essential, even with simplex systems. Section 5.3.9 covers warning systems for Category 3. And here's another difference. It permits a single alarm panel. This panel can combine the functions of a master alarm, monitoring the source equipment, and area alarms, monitoring pressure in specific zones.
One panel for everything. Where does it have to be?
It has to be located in an area of continuous surveillance whenever the facility is operating. So think maybe the main reception desk or a central station where staff are always present during patient hours. It can't be tucked away in a closet somewhere.
Makes sense. You need someone to actually see it.
Right. The sensors themselves, the pressure switches, vacuum switches, they're located out at the equipment in the mechanical room maybe. But the indicators showing the actual pressure or vacuum level and the alarm signals, lights, buzzers, must show up on that master panel in the monitored location. This ensures the operational staff are immediately aware if a system goes outside its normal operating range.
So the front desk staff or whoever's watching that panel needs to know what those alarms mean and what to do.
That's the intent. They need
Mhm.
to know who to notify immediately if an alarm goes off. Real-time awareness during operating hours is the goal.
Okay. Now, what about the piping itself? Getting the air or vacuum from the source to the treatment rooms. You mentioned sections 15.4.4 to 15.4.9 and 5.1.10. Sounds like there are specific rules there too.
Oh, definitely. This is where it gets really technical. Section 5.1.10, applied via 5.3.delio for Category 3, dictates the materials and how you join them. For copper pipe, which is common, you can't just use standard plumbing copper.
Yeah.
No, it has to be medical gas tubing, typically type K or L, that's been specially cleaned by the manufacturer to remove oils and contaminants. It will have markings on it like OXY or MED or VAC-C, often color-coded too.
So specialized materials and
Yeah.
installation too, I assume.
Absolutely. This is not a DIY job or something for a general plumber without specific certification. The joining methods are critical. Brazing is very common. It's like soldering, but at a higher temperature using a filler metal. Section 5.1.0.1.1011 requires specific brazing procedures, and the person doing the brazing needs to be qualified, often through an AS 6010 certification or equivalent. And here's a super critical step. While brazing, you must continuously purge the inside of the pipe with oil-free, dry nitrogen NF.
Nitrogen purge. Why nitrogen?
It's all about preventing internal oxidation. When you heat copper pipe up to brazing temperature with air inside, the oxygen reacts with the copper and forms black, flaky scale copper oxide on the inside surface.
Okay, that's bad.
Very bad. That scale can flake off later, travel down the pipe, clog fine filters and equipment, damage sensitive components like regulators or flow meters, and potentially even get delivered to the patient. The nitrogen purge pushes out the oxygen, creating an inert atmosphere inside the pipe so that scale doesn't form during heating. It's vital for system cleanliness and long-term reliability.
Wow, okay, that's a detail I wouldn't have thought of.
It's crucial. If stainless steel tubing is used, which is less common in dental but allowed, it requires specific orbital welding techniques and qualified welders. There are also some newer joining methods mentioned, like axially swaged fittings, but brazing with a nitrogen purge is the gold standard for copper medical gas lines.
And then at the other end where you plug things in,
Yes.
the outlets in the wall.
Right, the station outlets and inlets.
Mhm.
Section 5.1.5.1 mandates they must be gas specific. They use different physical connectors, diameter index safety system, DISS, or non-interchangeable quick connects for oxygen, air, nitrous, vacuum, etc. You physically cannot connect an oxygen hose to an air outlet or vice versa. It's a fundamental safety interlock.
That makes sense.
And each out-till inlet needs two valves, essentially. A primary valve you operate, and a secondary valve that automatically closes and seals the pipe when you remove the primary valve assembly, the part you plug into. This lets you service or change equipment at one station without shutting down the whole system or even other outlets in the same room. The requirements for Cat 3 outlets are in 5.3.5 and 15.4.2.7.
So you don't lose suction everywhere just because one hose is disconnected.
Exactly. Now, after everything is installed, pipes, outlets, source equipments, you're not done yet. You must perform rigorous testing before the system is used for patient care. Section 5.1.12 and the dental section 15.4.7 detail these tests.
What kind of tests? Just checking for leaks.
Leaks are part of it, yes, initial pressure tests, but it goes way beyond that. You have to do cross-connection tests. This is critical. You verify that each gas is only coming out of its intended outlet. You pressurize one system, like oxygen, and then check every single outlet for all other systems, air, nitrous, vacuum, to ensure none of the oxygen is crossing over. Then repeat for each gas.
Wow, that sounds painstaking.
It is, but absolutely necessary. Imagine getting pure nitrous oxide when you expected air, then there are. Initial piping purge tests. You flow a high volume of gas through each outlet to blow out any dust or debris left from construction, catching it on a white cloth to visually verify cleanliness. Purity tests. For medical air, you test to ensure it meets the standards for dryness, dew point, carbon monoxide levels, and other contaminants. Alarm tests. You simulate fault conditions, low pressure, high pressure, pump failure, etc., and verify that all the required visual and audible alarms activate correctly at the source and on the master panel.
This is all commissioning process.
Precisely. It often requires specialized certified personnel, sometimes a third-party verification company, to perform and document these tests properly. You need that formal verification that the system is safe and correct before it ever touches a patient. And one more piece on operations. The Responsible Facility Authority, or RFA, Section 5.1.11.1 requires each facility to designate one, and 15.4.9 applies this to Cat 23 facilities like dental. This person is the linchpin for ongoing compliance. They're responsible for overseeing the system requirements, managing the testing schedule, keeping maintenance records. They ensure safety isn't just a one-off at installation.
So someone has to own this ongoing process.
Yes. And related to that, for Category 3 medical air systems, Section 5.3.3.6.1 Chef Rue specifically requires the facility staff under the RFA's guidance to develop an emergency plan for what to do if they lose their medical air supply. Even at Cat 3, you need a Plan B.
Okay, that covers the pipe systems really thoroughly. It's definitely a serious engineering setup. Let's switch gears slightly. What about the gas cylinders themselves? The oxygen tanks, the nitrous tanks. How does NFPA 99 say they need to be stored in a dental clinic?
Storage. Yes.
Ah,
Chapter 11 is the main reference for cylinder storage, handling, and use. And Section 15.4.2.4 adds specifics for Category 23 facilities. The rules are all about preventing hazards, fire, leaks, physical impacts.
so where can you keep them?
Well, the location matters. If it's an indoor storage room or enclosure, the construction materials inside need to be non-combustible or limited combustible. You need enough space to safely move cylinders in and out, usually with a hand truck, and the area must be secured, locked, or otherwise protected from unauthorized people getting in.
Makes sense.
Temperature is also a factor. You have to protect cylinders, full or empty, from getting hotter than 52 degrees C, which is 125 degrees Fahrenheit. So no storing them right next to a furnace or in direct, intense sunlight through a window.
Okay. And what about keeping them upright? I've seen tanks chained to walls.
That's absolutely required. Section 11.3.6.5, 11.6.2.3, and 15.4.2.4.13 all emphasize that cylinders must be secured. Chained, strapped, in proper racks or stands, whatever it takes to prevent them from falling over. A falling cylinder, especially a large one, can shear off its valve and become a dangerous projectile. It's a serious physical hazard.
Right, I can imagine. Now, you mentioned fire hazards earlier, particularly with oxygen. What can and can't be stored near these gas cylinders?
This is probably the most critical storage rule. Oxygen and nitrous oxide are oxidizers. They don't burn themselves, but they make other things burn much more intensely. So Section 11.3.6.6 is strict. No smoking, NO open flames, NO electrical heating elements, basically NO ignition sources allowed within the storage location. If it's an outdoor storage area, that no ignition source zone extends out 6.1 meters or 20 feet.
There's 20 feet clear zone outside. Wow.
Yes. And just as important, Section 15.4.2.4.9 explicitly forbids storing flammable materials, think flammable liquids like solvents, or cylinders of flammable gases like propane in the same room or enclosure as your medical gas cylinders. You absolutely must keep fuels and oxidizers separated.
That seems fundamental. Any other location rules?
Yes, a couple more. Indoor storage rooms shouldn't open directly into areas where medical gas is being used, like treatment rooms, or other areas where oxidizers are stored. And if you have an outdoor storage enclosure right next to the building, it needs to be located more than 3.05 meters, 10 feet away from any windows or doors in that adjacent building wall. These are buffer zones for safety.
Okay, what about ventilation for indoor storage?
Ventilation is required, yes. It needs to comply with Chapter 9 of NFPA 99. If you use mechanical ventilation, an exhaust fan, there are specifics. The exhaust inlets should be near the floor, ideally within about a foot of the cylinders, because gases like nitrous oxide are heavier than air and can pool low. There are also minimum and maximum airflow rates depending on the room size. And ideally, the exhaust fan should be connected to the facility's essential electrical system if one exists, so ventilation continues even if the main power goes out.
So even the ventilation is specified.
It is. The code does mention slightly relaxed rules for very small quantities of gas, like 300 cubic feet total or less. But even then, the basic handling precautions in Section 11.6.2 still apply.
And what are those key handling precautions?
Things like always using the correct fittings, oxygen fittings, only for oxygen, never trying to force or adapt fittings between different gases, and a really important one. Section 11.5.2.2.3 prohibits transferring gas from one cylinder to another, transfilling within the patient care vicinity. That's something only suppliers should do in controlled environments.
Got it. So storing gas cylinders is way more than just finding a spare closet. It needs to be a dedicated, properly designed, and managed space.
Exactly right. The potential risks demand that level of care.
Okay, let's move on to the power source for all this electricity. It runs the lights, the chairs, the compressors, the alarms. What does NFPA 99, particularly the 2021 edition, say about electrical systems and, maybe more importantly, emergency power in a dental clinic, keeping that Category 3 context in mind?
Right. Electricity is covered in Chapter 6. And just like with the gas systems, the requirements are tiered based on the risk category. For a facility operating mainly at Category 3, the code points towards Section 6.6 for specific requirements, and it also heavily references NFPA 70, which is the National Electrical Code, or NEC.
So NFPA 99 and the NEC work together here.
They do. Now, the most direct mentions of mandatory emergency power for Category 3 systems in the source text relate back to the systems we just discussed. Section 5.3.3.6.13 clearly states that the emergency electrical service for Category 3 medical air systems must conform to Section 6.6 and NFPA 70.
Okay, so the air compressor needs backup power.
Yes. And similarly, Section 5.3.94 requires that the electrical power for the Category 3 warning systems, those alarm panels, must also comply with the applicable parts of Section 6.6 for Category 3 spaces.
So the alarms need backup power too. Even if the rest of the clinic goes dark, the air compressor and the gas alarms need to stay on.
That's what those sections mandate. They're deemed critical enough, even in a Category 3 setting, that they need an alternate power source that kicks in automatically if the normal utility power fails. This ensures the air supply continues and you maintain awareness of the system status during an outage.
What kind of alternate source? Like a generator?
It could be a generator or maybe a large battery backup system, UPS, depending on the load and duration needed. Section 6.7 talks about essential electrical systems, ES. While the really detailed specs for Type 1 and Type 2 ES in that section are geared towards hospitals, Category 1 and 2 areas, it lays out the basic principle. An EES has the normal source and one or more alternate sources. If a generator is used, Section 16.5.1.3 says it needs to be installed, tested, and maintained according to another standard, NFPA 110, which is specifically for emergency power systems.
Okay, so a full hospital-grade ES might not be required, but some form of reliable backup power is mandated for those specific Cat 3 systems.
Correct. The source material does mention components of the EES, like the life safety branch and the critical branch. The critical branch is described as powering things essential for patient care-specific lights, certain outlets, fixed equipment. While the text doesn't explicitly say this outlet in the dental chair must be on the critical branch, it points to the type of functions considered essential. It suggests that beyond the mandated air compressor and alarms, a facility's own risk assessment might lead them to put other key equipment or lighting on an alternate power source as well, even in Category 3.
So minimum requirements for air and alarms, but potentially more depending on the clinic's specific procedures and assessment.
That seems to be the logical takeaway. The code sets the floor with air and alarms for Category 3, but the principles in Chapter 6 suggest thinking broader about what's truly essential during an outage.
Anything else specific in Chapter 6 relevant to treatment rooms?
Yes, there's a point about grounding. Section 6.3.2.2.5 discusses special isolated ground receptacles, sometimes used for sensitive electronics. However, subsection B explicitly states these shall not be installed within a patient care vicinity.
Why not?
In patient care areas, the priority is maximizing electrical safety for the patient, often through multiple redundant ground paths. Isolated grounding compromises some of that redundancy for the sake of cleaner power. So, standard, reliably grounded outlets are the rule near the patient.
Okay, good to know. And like the gas systems, I assume electrical systems need maintenance.
Absolutely. Section 6.9 mandates a documented preventative maintenance program. This includes regularly testing things like circuit breakers and the batteries for any backup power systems. And just like with gas, Section 6.9.2 requires keeping detailed records of all electrical testing and maintenance. Documentation is key for proving ongoing compliance.
Right, you need that paper trail. Okay, let's pivot to a couple of specific areas you often find in the dental clinic. The radiology room for x-rays, and the sterilization area for instruments. Did the NFPA 99 source material we looked at have specific, detailed requirements for these areas in a dental context?
That's a good question, and based only on the excerpts provided for this deep dive, the answer is mostly no, not in terms of detailed, mandatory engineering requirements.
Really? Nothing specific for sterilization?
The table of contents in the source hinted at sterilization under Chapter 15, but the actual text with the requirements wasn't included in what we reviewed. So based purely on this source, we can't outline specific NFPA 99 rules for the design or systems within a dental sterilization area. Other standards might apply, of course, but not found here.
Okay. What about radiology rooms, x-ray rooms?
The source did mention radiology, but it was in Annex A, which is the explanatory, non-mandatory part of the code. Item APONT 6.7.5.1.3 suggests that facilities might consider putting automatic battery-powered emergency lights in special procedure radiology rooms.
Special procedure. Does that mean more than just routine dental x-rays?
It sounds like it might imply more invasive procedures happening under imaging, but even then, it's just a recommendation in the annex, not a shall requirement in the main code body for standard dental x-ray spaces. So again, based strictly on this text, NFPA 99 doesn't seem to impose specific engineering requirements on typical dental radiology rooms beyond general electrical safety.
So to be clear, based only on the NFPA 99 excerpts we have, the code's main focus for dental seems to be the gas vacuum systems, their storage, and the associated electrical needs, rather than providing detailed specs for sterilization or standard X-ray rooms.
That's an accurate summary of what we found in this specific source material. The heavy lifting in these excerpts regarding dental is definitely around that pipe system infrastructure and its safety support.
That's a really important clarification, sticking to what the source tells us. Okay, let's use that to recap and answer some of the listeners' initial questions directly. First off, did we find any minimum area or space requirements defined for dental clinics or treatment rooms in this NFPA 99 source?
No, not in terms of setting minimum square footage for rooms. The source material doesn't say a dental operatory must be X square feet or a clinic needs Y total area. The space requirements mentioned are functional, tied to the systems,
Like what?
like needing adequate clearance around equipment for maintenance access, needing enough room and storage areas to maneuver cylinder hand trucks safely, and those mandatory safety separation distances like the 20-foot clear zone around outdoor gas storage from ignition sources or the 10-foot distance for outdoor enclosures from building doors and windows. So while it doesn't dictate room sizes, the code's system requirements definitely influence the layout and demand certain functional spaces and clearances.
Got it. No specific room dimensions, but space needed for safe operation and maintenance. Second big question. Based only on this source, what are the absolute mandatory safety systems and requirements for NFPA 99 compliance in a dental setting? Let's nail down that list.
Okay, based on our reading of the Category 3 and dental-related sections like 5.3 and 15.4, piped medical gas vacuum. You must have these systems designed and installed per the code's Category 3 rules. That covers materials, joining, like brazed copper with nitrogen purge, valving, gas-specific outlets, warning systems. You must have the specified source and area alarms located appropriately under surveillance during operating hours and powered by an emergency source. Gas cylinder storage. You must store cylinders according to the rules, proper location, construction, security, temperature control, physical restraint, and critically, strict separation from ignition sources and flammables. Emergency electrical power. You must provide emergency power specifically for the Category 3 medical air compressor and the Category 3 warning systems. Testing and verification. You must perform all the required initial system tests, pressure, cross-connection, purity alarms before patient use. Ongoing maintenance and planning. You must implement and document an ongoing maintenance program for both gas vacuum and electrical systems. You need to designate a responsible facility authority, RFA, and you must have an emergency plan for loss of Cat 3 medical air.
That's a solid checklist derived directly from the text. And finally, just to reiterate for someone wanting to look this up, what were the key chapters and sections of NFPA 99 2021 we focused on for this dental clinic deep dive?
We drew heavily from Section 15.4, Dental Gas and Vacuum Systems, Section 5.3, Category 3 Systems, Chapter 11, Gas Storage, Chapter 6, Electrical Systems, especially Section 6.6 for Emergency Power, and Chapter 5, General Medical Gas Vacuum Requirements like piping and testing. We also touched on Chapter 4, Risk Assessment, Chapter 9, HVAC for ventilation, and Chapter 3 for definitions like single treatment facility.
Fantastic. That was, wow, a really detailed exploration of the code.
Yeah.
It makes it so clear that NFPA 99 requires a serious engineered approach to safety, even in a setting like a dental clinic that might seem less complex than a hospital.
It really does. It highlights that patient safety relies on this underlying infrastructure being robust, correctly installed, and meticulously maintained, regardless of the facility size. That risk-based approach means you can't just assume lower requirements, you look at the procedure risk, and the systems have to match.
And it seems zeroing in on those Category 3 requirements is the critical first step for navigating this code in the dental world.
Precisely. Understanding you're likely in Category 3 for these pipe systems, and then working through the specifics in sections like 5.3 and 15.4 for the gas vacuum, Chapter 11 for storage, Chapter 6 for electrical, that's the path.
So after diving into all this detail, the specific requirements for piping, storage, alarms, emergency power, testing, the RFA, what's the big takeaway? What's a crucial question for you, the listener, to consider from all this?
I think it leads to a really practical and important question for anyone involved with a dental facility. Given how specific and ongoing these NFPA 99 requirements are for systems we might take for granted, like dental air or vacuum storage, how do you move beyond seeing compliance as just a hurdle during construction? How do you effectively weave these detailed safety protocols, the required testing, the maintenance, the designated responsibility, into the daily operational culture and long-term facility management plan?
Shifting from checklist compliance to embedded safety culture.
Exactly. What systems, checks, or responsibilities might currently be overlooked that this code emphasizes as vital for protecting both your patients and your staff every single day? It really highlights the need for vigilance. And as NFPA themselves often state, navigating these codes for specific situations really benefits from sound judgment and, frankly, consulting with competent professionals who know this code inside and out.
That's a really powerful thought to leave everyone with. It's complex, yes, but fundamentally about safety. Thank you so much for breaking that down for us.
My pleasure.
And thank you for joining us on this deep dive into NFPA 99 and dental clinic safety. We hope it sheds some light on these critical requirements.